questions involving electrolysis. A couple of calculation questions, a couple of using the electrochemical series, and a couple of just looking at issues that you might have with electrolysis in general, and a couple of tricks you might have. First one is a multiple choice question. We say the total number of electrons passing through a cell is 0.9 mole. For this cell, A, the voltage must have been 10 volts and the time 145 minutes. B, 0.15 mole of metal was obtained. C, 0.8 mole of metal was obtained. D, the current was 10 amps and the cell was in operation for 145 minutes. Now, I can cross out 3 of these answers, okay, already, but I'm just going to do how to do the question in as well. I'm going to go, why am I crossing out these answers, and so on and so forth. Now, we haven't got what metal it was. So really, it's M something, question mark, plus an unknown number of electrons going to a solid, okay? For example, it must be something like this. We don't know what the charge is, we don't know how many electrons are going to be actually used. So because of this, we can't actually tell what mole of metal was obtained. To understand how many mole of metal was obtained, we need to know what our equation is to do some stoichiometry. So we can cross out B and we can cross out C. Both of those are incorrect because there's no way of knowing what the metal is without having a half equation. We don't know what the metal is, we don't know what the charge on that metal is, we don't know how many electrons are needed to make that metal solid. The next one I can cross out straight away is the voltage must have been 10 volts at the time 145 minutes. Why? Because we can't work out voltage from this information. Okay? Voltage needs to know amps, charge, and time. So we haven't got any amps here, so we can't actually work out the voltage. So what I'm going to do is I'm going to look at the equations to work these things out. So I've got Q equals IT. Okay, that's my first equation. It's Faraday's first law to understand that the charge is related to amps and time. To get my charge, I need to find out the number of moles of electrons multiplied by Faraday's constant. Okay, this is Faraday's second law, where the number of electrons is proportional to the charge. So my number of moles of electrons is 0.9. Okay, my charge is going to be, for my F, is going to be 96,500 because that's Faraday's constant. I work that on my calculator. 96,500 is going to be 86850. Okay, so that's my charge in coulombs. I then substitute it into here. Alright, and I work out what my amps are going to be. Actually, come to think of it, I can work out volts because I work out amps here. Anyway, we're moving on. 145 minutes and 10 amps. Should work out that, but I'm just going to work it out anyway. Both of these are 145 minutes, so I'll use 145 minutes as my time. Time must be in seconds, so it has to be 145 times 60, which equals 145 times 60 equals 8,700. So therefore, my I is going to be equal to Q over T, which is going to be equal to 87850 divided by 8600, which is going to be equal to pretty much 10. Alright, so 87 used over here. So 86850 divided by 8 equals 100.7. Alright, can't count. So that's my amps. Now, my next thing I need to know is my I can't work out voltage. That's why, because I've done it out by a factor of 10 here. So that actually should be 10 amps. Because in my calculator, you can see I've stuffed it up. and I've put in an extra 7 here, which is incorrect. So if I take that out and I do that again, it will work out to be the right answer. So 86850 divided by 8700 equals 9.98, which is about 10 amps. So this is the correct answer. The reason I was saying I can't work out volts is because I haven't got the energy, because we know that energy equals volts times amps times time. Because I haven't got that, I cannot work out my volts. I don't have much energy, I can't work out my volts. So there we are. First of all, by powers of deduction, working out this answer, and second of all, by actually doing the question and working out my answer there, I've got the fact that it is D. This question could have been done in about 30 seconds just by looking at it, or about 1 minute by actually doing your calculations on your calculator with minimal writing down there. But I've explained it in many different ways, so hopefully you've enjoyed that. Alright, second question in terms of electrolysis. Now, this one is to do with a system, and we're passing 4 amps of current through a 1 molar solution of magnesium fluoride for 4 hours. Now, what the first question says is, why is no magnesium solid obtained from this experiment? Can't write. Well, what we need to do for this is look at our electrochemical series. Hopefully I can get it all in, but I don't know if I can actually because it's a bit long. And I write down all the things I have in my system. I have magnesium 2+, first of all. I've got fluorine negative, and I've got water, because it's a solution. It's 1 molar solution, means I have a lot of water there as well. I go to my electrochemical series and I find all my species. I have this guy, I have this guy, I've got fluorine, which is up the top here. I've also got magnesium. Where's magnesium? Down here. And I've got water. To know what reaction is going to happen, I need to look at the highest on this and the lowest on that. The highest here is water, my lowest here is water. So therefore I have water reacting with water, okay, and therefore magnesium here does not form magnesium solid. So what I'm going to write here is, because water is a stronger oxidant than Mg2+. Oh, sorry, you can't really see that actually. So because water is a stronger oxidant than magnesium 2+, it is reduced before magnesium ions. Okay, so because the water is a stronger oxidant, it is reduced before the magnesium ions. Okay, and that's because we use the highest thing on this side and the lowest thing on this side. Next question is, what change could you make to this system to obtain magnesium metal? Now, the two things that you can do, one is by using molten magnesium fluoride instead. So heat it up till it's a liquid, and that means you have no water. Okay, this is a good idea. However, you're going to take a lot of energy to heat this till it's molten. The second one is use a saturated or a very strong saturated solution of MgF2. Okay, using a saturated solution of magnesium fluoride will make water less involved in this reaction. Okay, or a very concentrated solution of magnesium fluoride. Remember, because this electrochemical series is based on standard laboratory conditions, which means 25 degrees Celsius, 1 molar, and 1 atm atmosphere. Deviations from this will change how this works, and increasing concentration reduces the effect that play that water has in this in the system. Next question is, what mass of magnesium could be obtained from this system if the above changes were made? I'm going to go with this one here. If this change is made, what will happen? Now, to do this, we need to think about what's happening in this reaction. We've got 4 amps of current for 4 hours, and we need to use Faraday's laws. I'm going to write the Faraday's laws out now, quickly, and we'll discuss how we're going to use them. The first one is Q equals IT. That means charge in Coulomb equals the amps times the time in seconds. Then I have Q equals number of moles of electrons times T. Sorry, not times T, times F, being Faraday's constant. So I'm going to first of all work out my charge using the information that's provided to me. Where is it? 4 amps here and 1 mole of solution. So Q, so 4 amps and 4 hours equals 4 times 4 hours times 60 minutes times 60 seconds. So what is my charge? Is 4 times 60 times 60 equals that much times 4 amps equals that much charge. Okay, so there's my charge. That's how much is going through it. Work out my number of mole of electrons now. I'll go number of mole of electrons equals Q over F. So 96,500. No, other way around, equals 57,600 divided by 96,500 will equal my number of mole of electrons. So if I get that divided by the charge on 1 mole of electrons being F equals 0.597 mole, rounding it of course. Now, how am I going to use this? I need to find out the mass of magnesium. Magnesium, 2 plus 2 electrons goes to magnesium solid. I need to do some stoich using my number of mole of electrons. My number of mole of electrons going to magnesium is a 2-to-1 ratio. So for every 2 of these, I only get 1 of those. So I'll do some stoich anyway. Where are we? That means number of moles of electrons over 2 equals number of moles of magnesium over 1 equals 0.597 divided by 2 equals number of mole of magnesium, which equals, divided by 2 equals 0.298. Okay, mole. So that's my number of mole of magnesium. Notice every time I use my calculator, I don't clear it, I just use the next answer. Okay, so please do that every time you do a question. That's the number of mole. Then I come over here and go mass of magnesium equals the number of mole times molar mass, which means 0.298 multiplied by the molar mass of magnesium, which is about 23-ish, 23, 24 actually, I think, from memory. Maybe 23.9, but you'll use the, actually, you use whatever it says in your periodic table. Multiply the, multiply by 24 equals 7 point, I'll look for my significant figures by the way. Got 2 significant figures here, 1 significant figure here. So really, I'm going to have 7 grams of magnesium, okay, to 1 significant figure. And 1 significant figure here as well. So 7 grams of magnesium was made. That's using your first law and your second law, finding out the charge from our amps in time, finding out the number of mole of electrons from our charge and Faraday's constant, and then using our equation to work out how many mole of magnesium we have. And there's that question. It's a good question. These are very, very common, these types of questions, in your exams. So please understand how to use Faraday's laws properly. Alright, another great electrolysis problem. Let's have a look at this one. Now, we're going to identify our unknown metal with this one. So electrolysis was carried out on a solution of a metal nitrate with the formula of MnO32. 2.4 amps was passed through for 50 minutes through a cell, and then 2.48 grams of metal was deposited at the cathode. Identify the metal nitrate in the solution. Well, sounds like fun. What we understand is that the metal went to, so the metal ion went to a metal. So what we have is metal ion going to a metal solid, plus some electrons. What charge is this metal ion? It's a charge of 2+. Because 2 nitrates means this is a charge of 2+, means we had to have 2 electrons forming that metal solid. Okay, it's the first step. Because we don't know the metal, we try and work out what information can we find out about the metal. And I know the formula, so I can find the charge on that metal. I next look at what I can find out. I can find out from this my charge that came through it. My charge will be equal, from first law, Q equals IT. So that's my charge here. Got interrupted there for 2 seconds, but it's all good. So Q equals IT. My amps is 2.4 amps. 2.4 amps. My time is 50 minutes. So it's going to be 50 times 60 to bring it back into seconds. So let's do that. I'll do 2.4 times 50 times 60 equals, my charge is 7,200 coulomb. Now from this information I can work out, using his second law, Q equals number of moles of electrons times Faraday's constant. So therefore number of moles of electrons equals Q over F. So we have our coulomb, which is 7200, divided by F, which is 96,500. Always Faraday's constant. The number of is the charge on 1 mole of electrons. So I'll do that. Divided by 96,500 equals 0.075 mole. So I have this many mole of electrons. What good is that for me? I want to find out what my unknown metal is. What this can tell me is how many mole of metal I have. Because I know it's a 2+ charge on my metal, I can do stoic to work out my mole of this metal. So we've got number of mole of electrons over 1 equals number of mole of metal over, number of mole of electrons over 2 equals number of mole of metal over 1, means equals 0.075 over 2 equals number of mole of metal, which equals, divide this by 2, 0.037 mole of unknown metal. How is this going to help me find my metal? What I've got is a number of mole of metal, and I've got a mass of metal that we have as well. So what I can use is find my molar mass of my metal. N equals M over Mr. I rearrange this equation. I find my molar mass is equal to my metal, my mass, divided by number of moles, which equals 2.48 divided by 0.037. It's going to be a rather large number. I'm going to do 2.48 divided by my answer is 66.47, and that's my molar mass of my metal. So therefore, I search on my periodic table and I work out, I don't know, I think it's about copper. Gotta double check that though. How am I going to check that? Google. Give me 2 seconds and I'll find out what it actually is. Periodic table. And that's going to find out what metal it is. While I'm searching for this, I'll just walk you through it again. I saw amps and I saw minutes. So what I did is found out my charge. From my charge, I worked out my number of mole of electrons. With my number of mole of electrons, I knew I had a mass. Before that, I took my number of mole of electrons and I worked out my number of mole of metal. Okay, so every time you have amps and time, you can work out charge, you can work out number of mole of electrons. If you have an equation like this, you can work out your number of mole of metal. Once I had my number of mole of metal, I knew I had an amount of metal, in grams, I could work out my molar mass. So that's just what I did to work out this question. So, waiting for my Google to load up.